All right, everyone, welcome to the KVM development status session. So first one is a rant. So Marc, do you want to help me here?
Yeah, so I'm being the local renter. So as it's written here, there's two little reviewers, too few reviewers. Basically, there's Christoffer and I, and it's fairly obvious that we won't scale for very long. Actually, it's fair to say that we don't scale anymore. So that is starting to reduce the rate at which we can merge patches, merge functionalities after which people are. So we kindly ask those interested in seeing KVM on ARM picking up features a bit quicker to show up on the mailing list, start reviewing things. We don't expect people to know everything about the KVM infrastructure and the ARM virtualization extensions. It's fairly complicated. There's some ramp up, but we can help people with that. There's plenty of opportunity to review sometimes fairly minor patches and to give us a hand. And we would be really delighted to help people starting to review things. So yeah, that's about it. Please help us reviewing things.
Yeah, so all the patches go on a dedicated mailing list, the KVM ARM list, and RCC to LAKML, so it should be easy to find. So. Okay, so big picture stuff since last Connect. We worked through the VM system specification, which applies to both SAN and KVM and theoretically others. It's publicly hosted on the Linaro website. I've been meaning to send out a notice on the mailing lists, which I'll do once I get back from here. And we need to make sure that whatever is in there is actually also supported by KVM. So we've got most of that down, but still some things on flight. We merged all the big endian, little endian patches that Victor did, and Marc did the debug patches for V8, and that's been merged. And then we had a whole bunch of stuff concerning 64K pages. And that really is sort of the high-level view of what happened since last time. We have a bunch of stuff in flight. So I had to prepare these patches a while before Connect, so some updates. The read-only memory regions are, I think, they're at least in KVM ARM Next. I don't know if they're probably not in KVM Next, but they will go in for 3.18. So that gives you dash BIOS with QEMU that emulates a read-only flash ROM that you use for running a VM with UEFI, for example. You need that stuff. Then there's this VTTBR mask issue, which is basically that our stage 2 page table management was fundamentally broken, and originally there was one patch from Jungsok from Samsung that added 4-level page table support on 4K pages and 3-level page table support on 64K pages, and also adjusted this the VTTBR mask and stage 2 allocation stuff. But there was a number of issues with that. Then Joel picked it up. There were still a number of issues with it, and Marc and I have been basically working through that this week. So we hope to get patches out at the end of this week or early next week on this. Then we have a bunch of interesting stuff going on concerning the VGIC. So there was a cleanup series that I sent out a long time ago that was basically renaming and some random fixes. We got that straightened out during this Connect, and it's now in KVM ARM Next. Marc's dynamic VGIC sizing series was we also merged that during this Connect, so they'll both go in for 3.18. And then there's the Gig V3 emulation stuff from Andre. I started looking at it, but going back to the review question, we really need some help here. So ideally we can get it in for 3.19, but with the current pace of reviews, it's unlikely.
It's very unlikely. I mean, this is seriously hairy code. And another thing that doesn't help is that the Gig V3 spec is not public yet. It's under NDA with partners, so if there's, by miracle, any our partner in the audience that has access to the Gig V3 spec, it would be a very good idea to have a look at these patches and make sure that they do what they claim they do.
Right. So PMU support posted by a noob, not here, but they are also suffering from the same destiny. We need to review them basically. There were some high-level comments on there, so we're expecting a new version to go out there. Then there's the forwarding physical interrupt series. We worked through that quite a bit with Eric and Marc this week. So you'll send out a new version of that, I presume?
Yeah, as soon as I come back from holiday.
Yep. Okay. And then there's the irqfd patch series and the KVM vfio patch series from Eric, and we have some separate slides later, so he'll go into details of that. That's very much work in progress. So yeah, the VTTBR stuff that we covered earlier. Basically, what we needed is we need to tie the stage 2 translation to that of the logic of the host kernel. So if the host kernel supports walking 4 page tables, we also have to support 4 page tables. Otherwise, we have to come up with all the page table manipulation functions separately in KVM ARM from the rest of the kernel, and we don't have any good reason to do so yet. People can, if they have good use cases for it, feel free to bring it up. And also, there's a bunch of constraints, the actual hardware, and the fact that we tie the implementation to the host kernel. But we need to be able to tell user space what the maximum physical address we can launch a guest with is. So we need to add infrastructure for that as well. And this is also coming from us very, very soon. So that's pretty much it there. So on the VGIC patches, I covered that already. We merged it and clarified things, and pretty much we're waiting on reviews on Gig v3. Yeah, on the RMB8 PMU stuff, it's an RFC only. We are waiting for a new version, and if anybody, I was hoping that the author would be here, but if anybody has said something, you are here. Do you want to cover the status of that?
So still waiting for the comments on the PMU support. So
there were some comments already, right? So are you planning on sending out a new version of that, or?
Yeah, so I have to rebase it based on the IRQ support that Marc has already sent out for timers. So I'll do something similar for PMU, and then maybe it's. So I still need comments regarding the user space interface that I added for specifying the PMU IRQ number. So comments are welcome. So.
Okay, yeah, we'll try to get to it. RQ forwarding, do you want to say something?
So we have a number of issues when it comes to physical interrupt injection. So far, we've tried really, really hard not to consider injecting physical interrupts into a guest. There's only one exception so far, which is the timer. When the virtual timer fires, we inject the equivalent of a physical interrupt and do really a horrible hack to convince the timer not to fire repeatedly. Well, it's not very good, and that prevents anything that looks remotely like direct device assignment. So the idea here is to use a bit more of the GIC. The GIC has 2 modes, EOI mode 0, which is basically you EOI an interrupt, and that's it. You say the interrupt is entirely handled. EOI mode 1 is slightly different. It's a 2-phase handling where you first drop the priority of the interrupt, which means you can start taking other interrupt at the same priority. The interrupt is still marked active. So you show that this particular interrupt can't fire again. We're mostly talking about level triggered interrupts here. So that's clear. The second phase is to actually deactivate the interrupt. And the funny thing is we can do that directly from the guest. With this magical hardware bit, we can make sure this EOI triggered by the guest is seen by the physical GIC as a deactivate. So it's an interesting path where basically the interrupt injection path is still done in software, but the EOI of the interrupt is entirely done in hardware. So we use a lot more of the geek logic. The consequence of trying to enable that is that we need some hooks in the core, the Gen IRQ code of Linux, really, in the core IRQ handling. We need basically two hooks that, one that declares and annotates an interrupt as being forwarded to a guest. The other one is to be able to basically get and set the state of that interrupt. For example, you need to know if it's active or not, so that you can actually context switch that interrupt as part of the virtual CPU context. That's really important for the timer, for example. You need to know if you have an interrupt pending, regardless of the virtual CPU being scheduled to a physical CPU or another. So I've posted patches for that a while ago. I still don't have any answer from Thomas Gleixner, the Turn IRQ maintainer. Going to repost another series in a couple of weeks after getting some rest and doing a bit more tests. But so far it looks pretty good. It's being actively used by Eric for his irqfd and vfio stuff. And it's a lot cleaner from an implementation point of view. We don't have to do any silly hacks on the timer path to mask the interrupt, which means some guests that we couldn't run until now will be able to run. Apparently QNX is one. It really doesn't like the mask we place on the timer. So yeah, if anyone has comments on that, please do on the list. That'd be much appreciated.
So you don't know, there's no specific controversies with Thomas getting those patches accepted, we just need to push?
No, at the moment it's been really silent about it. I plan to talk to him at KVM forum. I know he'll be around for plumbers, but that'll be a good opportunity to have a good chat with that over a couple of beers.
All right, great. Yeah, Eric, do you want to cover the topic?
Yes, so we recently ported the irqfd framework on ARM. So for those who do not know this scheme, so it enables to register to associate an event FD together with a virtual IRQ. So meaning that when the event FD is triggered, the IRQ is injected by KVM. So the event FD handler is executed in KVM, so on kernel side. So this is a feature that is very important for KVM device pass-through, because it enables to largely increase the performance, which is quite mandatory. And also with that scheme, the completion of level-sensitive IRQ is handled in the VGIC, meaning that when the VGIC sees the end of the interrupt, it can trigger another event FD, which is called the resample FD. And on the resample FD, you can do typically the unmasking of a VFIO driver or anything else. Okay, so it enables to handle the life cycle of virtual IRQs on kernel side. So we decided recently to only support SPI, because for PPI it does not make so much sense. And so at the beginning we wondered whether we should use a GSI routing or not, and with Paul Makira's patch we do not need to use that feature anymore, so it simplifies the whole integration. So irqfd is used in VFIO use case, so KVM device pass-through, and also in VHostNet. And the current status of the patch is it's not yet upstream, but I think it's quite close to be. Yeah. Yep. So now we come to the integration of forwarded IRQ feature. Marc largely introduced before. So the purpose is to be able to forward IRQs of VFIO device. So we discussed with Alex Williamson about the best way to do this kind of integration, and it appears that the best is to use the KVM VFIO device to do that. the role of the KVM VFIO device is to do the connection between the VFIO driver and KVM. So we will use that KVM VFIO device to program in a consistent manner the IRQ chip to tell IRQ chip that this IRQ will be forwarded, and to inform also that the VGIC that it must properly handle the injection as forwarded. So the status of this patch is it requires cleaning today because we adjust the abstraction level of the API, but we are quite confident that it is the right way to do things, and it works. So meaning that it shows that we get better performance than when using a simple irqfd scheme, because we can have a VM switch spared on the completion of the IRQ, so it's quite important. And I will present in the KVM forum the benchmarks associated to that. Thanks.
Thanks. So there's been some questions throughout the week on basically how far along are we to sort of support the full enterprise OpenStack use case. So an important piece of that is the UEFI support. So Art, I don't think he's here, but he did some great work and made sure that the port of UEFI to the Vert platform works. So those patches are actually, I don't know if they're completely upstream or most of it is upstream, but sorry, they were merged. Okay, so that's really great. So I said that there were a few changes required to QEMU. Peter, were those merged or?
They're in a extremely long queue of things I must review.
Okay.
People can help there as well.
They're close to the top of Peter's list, so coming soon. And you need those patches on the KVM list that goes in for 3.18.
Yeah, it must be said that Art has done a really great job in identifying a number of bugs in KVM, and yeah, it's done really an awesome job. It's the first time we run a guest other than Linux under KVM, and yeah, that has shown a number of issues. Did really a great job.
Yeah. So
anybody who can provide patches to, I just want to say, anybody who can provide patches to UEFI and QEMU and the kernel is just really fantastic, and we need more of those people.
Yeah, definitely.
Good. So on the, let's see. So on the topic of enterprise use cases, Alex is also working on well, debugging support, so that you can debug a guest kernel with GDB and QEMU. So that might be useful for anybody developing V8 kernels who don't happen to have hardware debugging mechanisms. So you're working on that, and also live migration, or at least migration, basic migration support, and there are patches for live migration on the list for V7 from Mario, and they just need to be tweaked slightly for V8, and we need a way to test it. So all that stuff is coming within a few months. Do you want to update on the status?
Yeah, for the migration stuff, I think it's just got the VGIC active serialization to sort out for that. For the debugging, you can have software breakpoints now if you want a beta patch, but it should be in the next few weeks.
So while Art was doing this work, there was this sort of issue that we all of a sudden we thought that we had to go back and do instruction decoding for those MMIO instructions that that don't provide you decoding information in the exception register. But we've talked this over a bit at the.
It's a recurring problem. So maybe we can quickly describe the problem. So when you do an MMIO, when the guest does an MMIO, what usually happens is that generates a trap, because usually the guest is going to try and talk to an emulated device. So normally you get a decoding of the instruction, whether it's a load or a store, the size of the access, the target or source register. Get a nice decoding of that in the status register, except for a number of instructions. So any instruction that involves more than one register, or any instruction that involves a register write back. That's quite annoying, especially when some MMIO accessors have been written with that kind of instruction. So Linux doesn't do that, thankfully. And sorry?
It does in the PL041 driver.
Yeah, that needs to be fixed because it's clearly a bug in that driver with a handcrafted assembly. Sorry, but
I'm pretty sure that's there. So I'm pretty sure that's there deliberately because it's faster. Because the PL041 hardware is designed with basically it's got a FIFO, but the FIFO is mapped to a bunch of addresses, and I suspect the reason it's done that is exactly so that you can use STM and one instruction writes 4 FIFO words all at once.
Yeah, well,
so
I'm not sure that's with any current CPU that is actually a problem.
I would agree with that, but fiddling around with drivers for ancient dev boards is kind of tedious.
So okay, apart from a few noticeable exceptions, we hardly need that. But it's a recurring problem. So there's still the opportunity of adding instruction decoding to KVM. The main problem we can see is that because it's a code path that is hardly touched, it's going to be fairly difficult to make sure that it stays correct. And also the main issue I have with that if you want to do it in a safe manner, you basically have to perform a stop the world on the system, making sure none of your other vCPU can run to be able to read the instruction stream safely. It's from a performance point of view, it's also really, really horrible. Well, otherwise you can race against modification of the page tables on the other side.
You have some really weird cases where if you have a 32-bit wide thumb instruction that crosses a page boundary that you have to read in, it gets.
Also, you can race against the page being swapped out. For example, the page between your actual fault, and the time when you can start reading out from the virtual address or physical address you've resolved, the kernel decided to swap the page out, and now you're reading from network buffer.
I thought you got that anyway. There's at least one code path.
Oh, that's why we never read back from the instruction stream. There's no code for that in KVM at all. We never do it.
There was code, and it was reviewed by Ben Herenschmidt and Rusty back in the days, and there's an interesting long thread that goes through all those releases and conditions, and it is a bit convoluted.
It's scary.
But anyway, we don't have a clear decision on whether this stuff will ever be necessary or not. But we're not focusing on this for now. So if anybody can come up with a case where they say, well, we simply need this and prove it, then
if someone can provide a good use case on AMP8, yeah, why not having a look? But yeah, it's difficult.
So that's a good segue into Drew's work. Is Drew here?
Yeah.
You're right. So Drew did KVM unit tests, which was merged into Paolo's tree, right?
Yeah.
Yeah. So it's a basic self-test that just boots up a custom type VM and makes sure that it's alive, and then that's it. So if we were to do something like instruction decoding, we would have to write a unit test framework for that, and using that would be a great thing. So anybody who feels like writing some tests for KVM, we would be very happy to see that. Very happy to see some people supporting that effort. And it is something that we also need to ramp up on in Linaro as well.
Yeah.
Are the tests in sort of CI deployments done by hand?
Currently it's done by hand. The entire test framework is still somewhat in development. The only tests that are the only tests that are currently there are actually just self-tests to make sure the framework works. Once we start adding tests, and we have other type of CI things going on as well. Like at Red Hat, I see us using Bird Tester. The new name is Avocado to do our testing, and that will actually invoke KVM unit tests as part of its complete startup, shutdown, save, restore type of testing. So yeah, I did notice that this would be the type of thing that KVM unit test would be quite well suited for, particularly because Marc said it's not a path that would get exercised a lot in normal use. So, if we had a regression test in there, we could keep it.
Also use a bit of debug. Test with the debug.
Absolutely, feel free to add any sort of test workspace.
Okay, so that's pretty much all we had to sort of cover. So are there any questions from anybody?
So the ARM SMMU driver today really has no concept of the actual VMID, right? It enables this private VMID, disables TLV invalidation broadcast or DVM, and the SMMU specs themselves say that, at least from a hardware's point of view, it's strongly recommended that the hardware supports the DVM mechanism, which lets you do a TLV invalidated broadcast. So any thoughts on when that kind of thing is useful, and whether the SMMU driver should get the VMID and use that with the global VMID namespace?
So far, there's no direct relation between the SMMU driver and KVM.
Right.
So Worldicken, if Will is in the room, he's not. Worldicken is looking at that at the moment. But the way it looks at the moment is that we're not going to use DVM for that. We're just going to perform the necessary invalidation directly into the MM notifier whenever the page is being removed or something. And we don't plan to have. It's not completely clear whether or not we're going to share the page tables at stage 2. It's a possibility, but so far I haven't seen the patches from Will. I know he's working on it and he's got some good results, but I haven't looked at the patches yet.
Okay, I was just wondering if you've talked to the hardware guys and if it's clear why they strongly recommend that, because it doesn't seem like we're planning on using that mechanism.
I have no idea why they strongly recommend it. I think a platform without DVM is perfectly viable. You could have different use cases where DVM is actually could be generating a lot of traffic that you would need. So it really depends on your workload and the type of things you're trying to do. I'm not completely sure that for KVM, DVM is absolutely mandatory. So far, we've managed without. So, but again, we need to do some more testing, run that on actual real hardware. So far, most of the work is done on models, especially as we're looking at using the 2 stages for the SMMU, so that the guest actually gets its own SMMU.
Great.
But so far, we don't have any hardware for that, so we're doing everything on models. So performance is a bit hard to guess.
Okay, thanks.
Anything else? All right. Thanks, everyone.
Thank you.